We're trying to find a moment m that will keep our system in equilibrium whenever an input force of 1200 newtons is applied. And we're going to do this for different values of alpha. So we're going to start with alpha equals 0 in part A. So we're going to find some unknown lengths in our free body diagram. So to find the length AE, this is going to be 100 times the cosine of 0, which is equal to 100 millimeters. And we're going to find length BC, and this is going to be equal to AC plus AB. And we can do this because we know that alpha is equal to 0. So this is going to become 500 millimeters. And since we know that alpha is equal to 0, we know that from D to C is a vertical line. So B is only going to have an x component in its force vector, since there's only a horizontal component that is applied to this system. So we can write that the sum of moments about point C is equal to 0. And we can say that negative 1200, the input force, times 700 plus 500 times B is equal to 0. And solving for B, we get a force of 1680 newtons. And we can now solve for the moment that's required to keep the system in equilibrium. So we're going to write that the sum of moments about the point A is equal to 0. And we can write it as negative B times 100 plus m is equal to 0. And we know what B is, so we can plug in B, which will give us negative 1680 times 100 plus m is equal to 0. And solving for m, we get a value of 168 Newton meters. And this completes part A. And for part B, we're going to do a similar approach. So we're going to start by finding some unknown lengths within our free body diagram. So we're going to start by finding the length AE. So length AE is going to be equal to 100 times the cosine of 30, which is equal to 86.6 millimeters. And final length EB, this is going to be equal to 100 times the sine of 30, and this is equal to 50 millimeters. And now to find a length BC, we use Pythagorean's theorem. So we take the square root of 400 plus 86.6 squared plus 50 squared, and this will give us a length of 489.16 millimeters. And next we're going to find an angle theta from our free body diagram. So to find angle theta, we're going to write this as the tangent inverse of 50 over 400 plus 86.6. And this will give us an angle of 5.86 degrees. So we can now calculate for our force B by saying that the sum of moments without a point C is equal to 0. And we write this expression as negative 1200 times the cosine of theta times CD plus force B times CB is equal to 0. And we know all these values except for B. So we can now say that negative 1200 times the cosine of 5.86 plus B times 489.16 is equal to 0. And solving for B, we get a value of B that is equal to 1708.26 newtons. So now we can write that the sum of moments about a point A is equal to 0. And we can write this expression as negative B times the sine. This is going to be the sine of theta plus 90 minus alpha times BA plus M is equal to 0. So now you plug in the known terms. So we have negative 1708.26 times the sine 5.86 plus 90 minus the given angle alpha multiplied by 100 plus M is equal to 0. And solving this equation for M, we get a value of M that is equal to 155.9 Newton meters. And that completes part B.